Our second equation that we're going to look at has two square roots. So 3x plus 1, and then minus square root of x minus, well, x plus 4 is equal to 1. So from before, we know that if we isolate a square root and square the function, we get possible equations, right? So we're going to follow that procedure, but it's going to be a bit more complicated for our situation. So to solve it, or to isolate this square root by itself, we're going to add square root of x plus 4 to both sides. And so when we do so, we get square root of 3x plus 1 is equal to 1 plus square root of x plus 4. Okay, and at this point we're going to get the power of both sides using the power property, which states that whatever satisfies this equation is going to be contained in the power of the equation. So we get, it's nice for one side because we get rid of the radical, but on the other side it's 1 plus square root of x plus 4 times 1 plus square root of x plus 4. So we get 1 squared plus twice x plus 4, and then the third term is x plus 4. And that you can use the box method, you can use vertical multiplication or distributive property to get this part. So it's nice, we got rid of some, but we still have this. So we're going to repeat the process. We're going to isolate for this, and then we can take the square of both sides. So let's subtract 1 from both sides. And so I'm going to do a few operations at the same time. Subtract x from both sides, and then also subtract 4 from both sides. So my result is 2x, and then it's 1 minus 1, which is 0, and then subtract 4. So 2x minus 4 is equal to twice of x plus 4. And my next step is to divide through by 2. So if I divide through by 2, I get 2x over x, or over 2 is just x, and then 4 divided by 2 is 2, and then I get x plus 4 on its own. So now we repeat the process, so we're going to square this as well. And so on one hand we get x plus 4, which is what we want. We don't want the radical anymore. And then here we get x squared minus 4x plus 4. And so if you're not comfortable with the power of this, you can do it out by the lattice or the box method, or vertical multiplication, or distributive property. Now I have a lot of things to work with, so I'm going to subtract 4 from both sides, and that ends up canceling everything. And then I'm going to subtract x from both sides, so I have x squared minus 5x is equal to 0. And in a scenario like this, I can factor out an x because they both have x's. And here's my two possible solutions. So if x equals 0, this entire thing is true, and also when x minus 5 is equal to 0, the above statement is true. So that means x is equal to 5 or 0. But remember, with these types, we have to plug it into the original to make sure that it works. So let's try 0. So we get square root of 3 times 0, which is 0, plus 1 is 1, minus 0 plus 4 is just 4. And if we do that, it's 1 minus 2, and we get negative 1. So here, since we had 1, it's not equal to 1, so 0 is not one of the solutions that we're looking for. And now we got to try out 5. So we get square root of 15 plus 1, which is 16, minus square root of x plus 4, so this one we get 9. And so this one is 4 minus 3, which equals 1. So x equals 5 works, x equals 0 does not. So we get our solution set is just 5. Because of the power property, when you take powers of the equation, there will be additional things, or there can be additional solutions that aren't solutions to the original.